Hello everyone, today I would like to show you a very powerful universal automation setup in the GregTech New Horizons modpack that you can build starting from LUV tier. Though the full potential of this setup is unlocked at UV tier when you have access to stocking input hatches. Before them you can build a setup that utilizes P2P tunnels that I will also show today. Of course, item-only machines doesn't have that problem, so their full potential is unlocked at LUV tier. This automation makes use of a very powerful component in AE2 called the toggle bus. Because of that, I like to call it toggle bus universal automation. Before I explain how it works and show you how to build it, let me tell you about all the advantages that this automation has to offer. Pattern space. You can have as many patterns as you want for a machine. The number of input subnets is not limited by physical factors like hash space on your multiblocks. You can also have duplicated circuit types to distinguish priority between specific patterns. Deterministic priority. Speaking of priority, you can determine the importance of an interface simply by its physical placement. The closer it is to the subnet controller, the higher its priority. It will effectively pause any drafts that are farther down the line until the primary task is finished. Parallelization. You can hook this up to however many machines you want. There are only 2 hatches needed per machine, and this can even be wall-shared between 4 multiblocks. Non-consumable support. Of course, this automation also supports all non-consumable items, also these that are not ignored by blocking mode. Passive automation. Because of how the priority logic works, you can utilize your machines to passive certain recipes whenever there are no active on-demand crafts. Responsiveness. With a little bit of help from GT covers, you can make machines wake delay non-existence and the recipe switches instant. These are the reasons I think this automation is even better than crafting input buffers, which have space limitations on the machine surface and require you to spam a lot of proxies to parallelize. Now that we've covered all of the aspects this automation has to offer, I will show you how to build it and explain how it works. Let's begin. We will go over the base setup first. You don't have to build it exactly like me, but you can of course. Make sure your toggle buses are in the correct orientation. The normal toggle bus should face the side, while the inverted toggle bus continues the main path. Also pay close attention to which side of the cables they are placed on. Make sure these storage buses are set to extract on. This step isn't strictly mandatory, but it allows the white subnet to also act as an output network if you also wanted to do that. Don't forget to color the ME chests. They should be completely separated from the colored networks. Let's power them with an additional quartz fiber. Now it is very important to set these storage buses to a higher priority. You might wanted to ask why I am using machine holes here. Super chests can be very buggy in this specific setup, and standard chest buffers tend to cause significant server lags when you build them a lot. Machine holes are the perfect block to use here because they have only one item slot, so they don't lag at all. You can adjust the detector cover update tick rate here. I will leave it at the default 5 ticks. For quick crafting, you don't really need it to be any faster. As a side note here, the fluid terminals that I am placing are removed from GTNH 2.9 versions, so if you play on that or higher, you don't need them. Remember to insert advanced blocking cards on the subnet side, and on the mainnet side, remember to active blocking mode with smart mode. Make sure that all of the networks are powered. Insert the storage cells. And this setup is complete. Of course, if you only need items support, you can remove all of the fluid storage cells, super tanks, and fluid terminals. These two slices are now complete and ready to be copied as many times as your factory needs. Now let me show you how to connect that setup to a multiblock. I like to share the stocking hatches as much as possible, in this case 1 hatch per 4 machines. Remember to lower the slot refresh time. I usually match it to the 5 tick rate of the item detectors in the main setup. Also, be sure to click Receipt Check on Changed. If you are using standard stocking hatches before UHV, you will have to manually set all the fluids here. So how does this actually work? It's surprisingly simple once you see the logic. When the AE2 system pushes a pattern to the subnet, all items and fluids first attempt to enter the machine hull and supertank. Anything remaining is inserted into the ME drive instead. The covers then detect the items and fluids and output a redstone signal to the cable with the toggle bus. This triggers two things. First, it disconnects all the other subnets further down the line. This is why interface position determines the priority. And secondly, it opens the three storage buses on our subnetwork. One for non-consumable items inside the ME chest, and the others to allow the system to see the entire subnet. Because of the priority settings, the ME drive is always emptied before the machine hull. This is vital. We don't want the toggle bus to flip back before the craft is fully processed. Once the subnet is completely empty, the detector covers stop the redstone signal, allowing the next subnet in line to connect and begin their work. Now that we've covered the basics, I will show you how to make this work with fluid recipes before you unlock these stocking hatches. We will use the property of P2P tunnels to spread fluids evenly between all the hatches. First, remove the fluid storage cells and tanks from the setup if you haven't already. We are going to create a shared fluid network between all subnets. Place 8 fluid tanks like so. You can use more or less depending on your needs. Use the highest tier fluid pumps you can afford, placing them between two tanks and on the other side. I will explain why we push from one super tank to a second one in the explanation part. Next, place fluid P2P tunnels on the output side and connect them to the wide network. Now we will create a subnetwork that guarantees only one network can craft at a time. Ensure all storage buses here are set to extract only to prevent accidental insertions. Extremely important note here. You must disable smart blocking and keep the blocking mode enabled, of course. The smart pushing logic completely breaks this P2P setup. When hooking up the machines, make sure the number of machines, or more specifically, the number of quadruple input hatches, is a power of 2. This is critical for the P2P fluid splitting to work evenly. I share quadruple input hatches whenever possible. You will still need stocking buses with autopull, lowered refresh time, and receipt check on change. Place a fluid P2P on the input hatch. Now choose one P2P tunnel from the super tanks and connect it to all of the other ones. You can use advanced memory card here to make that process easier and faster. One final rule for your patterns. You must multiply the pattern output by the number of quadruple input hatches minimum. If you don't do that, the machines won't start because there won't be enough fluid to satisfy the recipe after split. So what changed in this setup? We lost the ability to determine priority because any pushed pattern blocks every other interface via the green network. You also can't really passive any recipes at the end of the line if they require fluids. As for the fluids, all networks share the same tanks, which immediately push fluids to the machines. This is why fluid-only recipes won't work here. There is no anchor to allow a circuit from the MHS to appear in the machine. If you're wondering why we push the fluids between two fluid tanks before entering the machine, quadruple input hatches have a persistent mechanic, likely a bug, where they hold onto a fluid for one additional tick, even after it's been used up. This makes it impossible to push a different fluid if the slots are occupied by a ghost fluid. By adding that second tank, we delay the insertion by 1 tick, bypassing the bug entirely. It might be fixed by the time you are watching this, but you would have to check it yourself. You can really apply this automation to anything you want. As for an example, I will show you the automation on DTPF. It is modified a little bit to store the catalysts in a subnetwork and also exposes it to the mainnet when nothing crafts. And that would be everything I wanted to show you today. I hope that you enjoyed this tutorial and thank you for watching.